is okay with everybody, I'll just go with this screen. Does that look okay? Yep.
You may want to put your notes, move your notes down a little bit.
Oh,
so
yeah.
A little bit bigger.
Okay, well, let me see if I can get it into slideshow.
No, okay, that's fine, that's fine.
I mean, you're right. I mean, I don't want my notes to be seen, actually, if you want to know the truth. I don't know how to get rid of it.
Okay, you can try the reading view.
Reading view?
Yeah, so it's at the bottom of your screen, kind of the one that looks like a book. I'm pretty sure that's the one.
Would that give me my notes, though? I don't want my notes.
No, I won't give you your notes.
Oh, really? Okay, this is going to be fine then. Okay, let's try.
Perfect.
Learn something new every day. That's what I've noticed. All right, so I guess what I'd like to present is on the Ministry of Transportation in Ontario, Canada's new concrete pavement specification. So a couple of things in my introduction would be first to say, obviously, Ontario, Canada, we've got a wet freeze climate, lots of application of de-icing salt, and that's the kind of environment that we're building our concrete pavements in. So we need them to be very durable in a wet freeze climate, high application of de-icing salts. The other thing I wanted to do is thank, obviously this is my presentation from MTO, so the concrete section, Melissa Titherington, did all the work here and consulted very widely and broadly with other experts from across the concrete world. So many thanks to those folks like Peter Taylor and Shraz Tayabji and everybody else that's helped us update our concrete pavement specification. So the specification itself, we had a spec in place since 1998, been occasionally updating, and then in 2018 we did this major update, and the changes were to address premature concrete joint deterioration, also to improve pavement texturing. You can tell how old the spec is. We were moving from California Profilograph high-speed inertial profiler. We also tightened our smoothness requirements. And there was a move from contractor quality control testing for acceptance. We moved to owner quality assurance testing for acceptance, and we added some referee processes. And finally, an insoluble residue requirement for fine aggregates, which was to improve our microtexture, so frictional properties. The main driver, I would say, was this premature concrete pavement joint deterioration that we were seeing. So unfortunately, you know, we love concrete pavements, but this was just one of those nightmares that happens sometimes. After about 8 years of construction, we started to see some major joint deterioration. And this is, you know, you can see we had a terrible ride on this piece of pavement. That's what the joints look like. Even when we cored joints that were looking fairly good, we found that there was significant level of damage below the joint sealant. So in order to address this kind of horrifying problem, we decided we needed to definitely, first of all, do an investigation to look into the causes of this. Obviously, not all our concrete pavements look like this. And then we realized after that we needed to address our concrete material properties and our joint design. So again, just more pictures of the distress, and you can see it was quite obvious, both transverse and longitudinal joints, and quite badly deteriorated. As I mentioned, we had some really bad joints, but we also had some joints that looked fine, so that was good. But unfortunately, when we cored those joints that looked okay, we found deterioration lurking below the surface. So here's an example here where we had, you know, obviously deteriorated joint with a very widely deteriorated area, but when we cored through the good-looking area, we found that deterioration at depth. Again, this is a good-looking joint, but when we core it, we see that deterioration is lurking below the joint saw cut. And this is another picture of that as well. So from the surface, joint looks good, but when you core it, you're seeing that deterioration. I would like to emphasize that if we cored anywhere else in the pavement, we're not seeing this deterioration at all. It's only occurring at the joints. So, before we make a major change to our specification, we also want to know, is this happening on any of our other highways? So we carried out an investigation of other concrete pavements in the province. So for example, Highway 401 in the Windsor area, which is a very different climate, much more southwestern Ontario, and also Highway 410 in Brampton, which is basically in the Toronto area. These concrete pavements were not showing any signs of deterioration at the surface, but when we did some coring, we saw that this freeze-thaw damage was occurring, although much, much less severe than at Highway 417. So here's just an example from, perfectly good-looking core on Highway 410, and you could see that that damage was occurring, but much less than on Highway 417. And again, just showing the protected area from the joint sealant, but then this freeze-thaw damage, which is basically flaking off the concrete mortar in the core. So the outcome of the investigation, obviously we cored 3 different highways. We saw some degree of this premature joint deterioration due to freeze-thaw at all the different locations, although the level of deterioration could vary, first of all, between the different contracts and locations, but even between the stages of the same contract. So the one where we had that horrific damage was actually stage 2 of the westbound lanes of Highway 417, which was a 3-stage contract. The highway is located in sort of northeastern Ontario between, it's the major highway connecting Ottawa to Montreal. That particular stage of concrete pavement has been an ongoing problem for us. So this is the same one, if you recall me coming to this TRB meetings over years to talk about the same pavement. So we also had the situation where the dowel bars were all misaligned due to dowel bar inserter issues. And this is actually the exact same stage of pavement that led us to introduce the MIT scan for our joints to make sure that we had good dowel bar alignment at our joints. So, it's been a bit of a nightmare. Many of the joints were visibly deteriorated, as you saw, and actually last year we reconstructed this pavement. So it was built in 2005, so it was reconstructed after only 15 years in service, and that's certainly not what we're expecting to get from a concrete pavement. On the other hand, like the other stages and the eastbound direction, we're not performing that badly, but the cores, we did see some deterioration at the surface, and then the cores revealed that severe deterioration. And then the 410 and 401 had no deterioration at the surface, but we were seeing that, to a much lesser extent, freeze-thaw damage at the joints. So the contributing factors, especially on 417, when you have a pavement like that, that's you can look at the quality of the concrete and what's gone wrong and come up with some really good conclusions on what will lead you to get this degree of failure. So one of them was the marginal quality of the concrete. So we had requirements for concrete strength, but our strength requirement was 30 MPa, and the concrete itself was very well. It was meeting the 30 MPa plus or minus. So there was no effort to go to a higher strength concrete there. We also had permeability and air void issues in that pavement, and as I mentioned, it's a wet freeze climate. So our more modern concrete concrete material specifications have requirements for permeability and air voids, which we did not have in this contract. And so when we looked at those systems, they were very marginal. Similarly, as you can see, we had saturation at the joints. So the joints were not functioning very well. They were holding water, whatever we can attribute that to, that was certainly leading to this freeze-thaw damage. So this led to us making major changes to the spec. The three major changes we made to address that would be, one, we changed the concrete material properties, which I'll talk about. We also increased our allowable slag content, and we implemented a new joint design. So in terms of the material properties, as I mentioned, our old spec had a 30 MPa concrete requirement. We've changed that to 35 MPa compressive strength minimum, obviously, and that's tested on cores at 28 days. In terms of permeability, we introduced a requirement for a maximum of 2,500 coulombs using the rapid chloride permeability test, and that's tested on cores. And then we added the air void system, so a requirement for a minimum hardened air content of 3% and maximum spacing of 0.23 millimeters, again, tested on cores. One of the other things we did in consultation with experts was to increase our maximum allowable slag content. So we had allowed up to 25% slag. We changed the spec to allow up to 30% slag, and that was to improve the resistance of the concrete to de-icing attack in a saturated freeze-thaw environment. Our big concern on the use of slag over the years, and the reason we limited to 25%, was because of concerns with scaling. So we added a 3-year scaling warranty as well. In terms of the new joint design, this is a huge change for us. So our previous joint design was your typical saw cut with reservoir cut and backer rod. And so it was a huge change to move away from that. So what we've gone with now, and this is to minimize that sort of saturation of the joints that we were seeing, is we've gone with a single saw cut, minimum width 6 millimeters, and then the use of a low modulus sealer. So a sealer that will easily flow and fill up that saw cut. And this was, quite an extensive discussion was held on this. This is something that our neighbors to the south are using in New York, or had been using in New York, and they would have similar climate to us. And it's also outlined in the ACPA technical bulletin as a way of filling joints. So this was a huge move for us. And so this is just showing our old joint design, which is the hot poured rubberized sealant in this reservoir cut. So an initial saw cut, reservoir cut, joint sealer and backer rod, versus our new full depth joint filling. So we just have a single saw cut and fill the whole thing with sealant. Just some photos from the field. This is showing the 6 millimeter saw cut. And this is showing how to allow the material to flow to the bottom of the saw cut and fill the full saw cut. So these are some cores to verify that that's what happened in the field. And here's a cross section to show the same thing. So 6 millimeter saw cut, and then low modulus sealant that flows and fills the entire saw cut. Other changes we made to the spec, I mentioned we moved to owner quality assurance for acceptance. So in the past, we had contractor quality control for both smoothness measurements and for MIT scanning and dowel alignment. And so all we did was took that back in-house. And we, on the smoothness front, so we were moving from the California profilograph to the high-speed inertial profiler, and we also tightened our smoothness requirements. And so this is a mean roughness index in meters per kilometer. So apologies to everybody who doesn't use meters per kilometer. So we were using, a bonus system. So if you achieved very good smoothness, you got a bonus, so less than 0.5. Or equal to 0.5 if you got the 1.2 bonus, and then different ranges of bonus up to 1. Once you hit 1, that was a full pay, and then a greater than an MRI of 1, you would be in a penalty situation. In terms of other things that we implemented, we also moved away from transverse tining. One of the things that we have, challenges we face with concrete pavement, is the noise from the transverse tining. So we've moved to longitudinal grooving, and it gives a much quieter pavement and a really great ride. So here's some photos from that, showing the grooving depth. And finally, so one of the things that we have very high traffic volumes on our concrete pavement, and we wanted to do everything we can to improve pavement friction. One of the things that we've had in Ontario is some of our concrete pavements, we've been using a carbonate fine aggregate, and we were not getting that sort of micro texture from the surface of the concrete that we wanted. So what we did was instituted a minimum insoluble residue content of 60%, and that is basically to restrict the amount of carbonate aggregate that is in the fine aggregate and to improve the pavement frictional performance. So in terms of, the spec was implemented in 2018, and so we've had a number of contracts. We have another one going out this year with the spec. And this is just to show you the results that we had. So in terms of strength, as I mentioned, we had moved to a minimum requirement of 35 MPa. Now you can see that our average result was 50 MPa, so we're getting very good concrete in terms of strength. In terms of air content, our requirement was a minimum of 3% air voids. We were getting 4.6%. And the spacing factor, our maximum was 0.23, and we were getting 0.156 as an average. One of the things that there was a lot of concern, I would say, from the concrete industry about the RCP. We had a maximum of 2,500 coulombs, but our average was 1,377. So we were able to meet, the contractors were able to meet that RCP without issue. And then finally, a huge improvement as well was on our smoothness. So we had an MRI of 1 meter per kilometer being our maximum. And if you exceeded that, you would get a penalty. But the average that we got was 0.698. We did allow some sections to be diamond ground. So this is just sort of a distribution from the contracts. So you can see the compressive strength spec limit was 35 MPa, and you can see just the distribution of all the different test results. We had nothing below 35, and so we were very happy with that. And then in terms of the rapid chloride permeability, again, so the spec limit was 2,500 coulombs, and you can see a distribution of all the results there. So we were getting very good results on our RCP as well. So our new specification resulted in improved concrete properties. We implemented a new joint design to address joint deterioration. We definitely got a smoother pavement and improved ride quality with the longitudinal grooving, less noise as well. And with the insoluble residue getting better frictional properties over the long term. That's what we're hoping for. So, and the outcome to date has been that the contractors have been able to meet the new requirement and receive full pay for the work. Thank you very much.